Hi there. Today we're going to discuss similar figures. Objectives and standards. Today we're going to find missing measures of similar figures, and then we're going to use scale factors to solve problems. Our standards are 7.rp.2. The vocabulary you're going to need to know for today is similar, congruent, and corresponding parts. Similar figures. Similar figures are figures that have the same shape, but not necessarily the same size. If two figures are similar, then the following two things happen. The corresponding angles are congruent or have the same measure, and the corresponding sides are proportional and opposite corresponding angles. Okay, so here's an example, model ABC and XYZ. Again, they're not necessarily the same size, but they are the same shape. So corresponding just basically means that they have the same relative position. So like A would correspond with X, B would correspond to Y, and C would correspond to Z. In the same token, when we're talking about sides, we can say that AC corresponds to XZ, and AB corresponds to XY, and BC corresponds with YZ. Okay, they have the same relative position, they have the same angle measurements, so that's what it means for it to be corresponding. Now here, figure ABCD is similar to EFGH. Now, when they are similar, they have this symbol that's a tilde. I like to call it a squiggly. But similar figures have corresponding parts. So that just basically means that their line segments are corresponding. So like AD is corresponding to EF, and another example would be DC corresponds with HG. Sometimes they're not as nice where they'll have them all lined up. Sometimes the second figure is kind of turned around. So just be careful when you're naming corresponding parts. Okay, and then our last thing, since corresponding sides are proportional, you can use a proportion or the scale factor to determine the measures of the sides of similar figures when some measures are known. Okay, so as our notes, how to find the missing measures in similar figures. So step 1, set up a proportion of corresponding sides, and you're going to place an X for the unknown value. And then step 2 is to solve the proportion. So here's my first example. These figures are similar and find each missing measure. So since ABCD is similar to DEF, the corresponding angles are congruent and the corresponding sides are proportional. So what we're going to have to do is we're going to have to set up proportions, okay, of corresponding sides. So I know that AC corresponds to DF, and I know that BC corresponds to EF. Okay? So I think it'll be a little easier if I set up a highlighter for that for you. All right. So now what we're going to do is we're going to substitute any values that we know, and any ones that we don't know, we are going to write an X for it. So we know that AC is 4. We know that DF is 12. BC is 6. And then EF, we really don't know what that is, so we're just going to call it X. Now that we have a proportion, we know how to solve this. So we have 4 times X, and we have 12 times 6. All right, so then 4 times X equals 4X. Then 12 times 6 equals 72. So by dividing by 4 on both sides of the equation, we're going to get that X equals 18, and our units are in centimeters. So all we basically did was we set up a proportion of the corresponding sides, substituted values right over here, and over here we solved a proportion. Okay, I'm going to do a couple more examples with you. So here is our STU figure with WXYZ. So the corresponding sides are proportional. Now, if you look here, um, the second figure is kind of twisted around or inverted. So we just have to be really careful with what corresponds with what. So we know that RU corresponds with WZ. And then we know that RS corresponds to XW. Okay, now all we're going to do now is we are going to um, solve a proportion. So RU is 28, WZ is 4, RS is 49, and XW is X. Or I'm sorry, it's D, okay, because we don't know what that is. So we have our cross multiplication or our cross products to do. So we have 28 times D equals 4 times 49. Okay, when we do that, we should get 28D equaling 4 times 49 is 196. Our letter D is being multiplied by 28, so we're going to divide by 28 on both sides of the equation. So D is actually going to equal 7 feet. And we can actually call D XW or WX, whichever one you want to call it, um, just to be thorough. Okay? All right, so I'm going to just give you two more examples with shapes just so that we can get comfortable with it. At some point, you don't have to start doing the letters of it, and you can kind of set it up when you're comfortable. So I'm actually going to do that with you now. So I'm going to set up the corresponding sides AC and MO. So I know it's 12 over 3. And then my next pair of corresponding sides is CD, which is 33, and that corresponds to OP, which is X. Okay, so in this problem, I just kind of skipped the step where I actually wrote out the letters. AC corresponds with MO, and I just kind of went ahead and I started with my proportions. As soon as you're comfortable with that, you can start doing that as well. All right, so now we can do our cross products, 12 times X and 3 times 33. Now I'm going to multiply my cross product, so 12x and 99. Now I have my x that's being multiplied by 12, so I'm going to divide by 12 on both sides of the equation, and I'm going to get an answer of x equaling 8.25. They really didn't give us any units, so I'm just going to keep it as x equals 8.25. And here's my last one just with the shapes itself. They actually don't give you any letters on this, so we're just going to set it up like normal. We know that 10 corresponds with 5, so I'm going to write 10 over 5. And then we know that 24 corresponds with X. Okay, again, I didn't need to set up with my letters, so I'm going to do my cross products. So 10 times X and 5 times 24. So now I can multiply those. So 10 times x is 10x. 5 times 24 is 120. My x is being multiplied by 10, so I'm going to divide by 10 on both sides of the equation. And x is going to equal 12. All right? All right, now that we've gotten through the shapes, I want to start going into word problems, and I want to start going into like real life models. So an architect is using similar triangles to design a decorative window for the entrance of a new office building. If ABC corresponds to DEF, find the line segment of DF. Okay, so what I want to do is I just want to kind of point them out. So we have EF right here, and EF kind of corresponds with CB. okay? And then we also have the hypotenuse, so DF, oh, that's not a good color for that. DF kind of corresponds with CA. Okay, so I'm going to write that out in letters. The reason why I'm doing that is because you see how one of them is kind of flipped around, and so it's very difficult to see what corresponds with what. So I'm going to start with EF. That corresponds with CB. And then we have DF corresponds with CA. So let me start filling in the numbers of this. So EF is 9 and CB is 18. DF is, I'm not sure, so I'm going to call it X, and I'm going to see that CA equals 25.5. Okay, so now I can kind of do this by solving proportions, and I'm going to set up 18 times X, and then 9 times 25.5. All right, so 18 times X is 18X. 9 times 25.5 is 229.5. And so my X is being multiplied by 18. So I'm going to divide by 18 on both sides of the equation. So X is going to equal 12.75 inches. Okay, so that missing side length is 12.75 inches. Now, for my last example, this example actually doesn't have a diagram. Sometimes they're nice and they give you like a real life example. Here they just kind of tell you in words what it is. So it says nested boxes, which basically are boxes inside of boxes, are a series of boxes that fit inside one another. The faces of the boxes are similar rectangles. A face on the larger box has a length of 24 centimeters with a width of 13.5 centimeters. If the width of the face on a smaller box is 9 centimeters, what is the length of the smaller box? So here it would be really helpful if you kind of just drew a picture. So this is my big rectangle, and this is my little rectangle. So I know that my length of the box is 24. I'm actually going to take these and I'm actually just going to flip them real quick because I want them to be kind of true to what they're talking about. Okay, so they're saying that the length is 24 centimeters and then the width is 13.5 centimeters. Okay, that's in the big guy. And then the little guy, the width is 9 centimeters. And then so this one we're not really sure of. So here you kind of can just make a diagram yourself and then you can kind of set up your ratios as you see fit. So we know that the 24 is going to correspond to the X. And then the 13.5 in the bigger one is going to correspond to the 9 in the smaller one. So here I can multiply whatever I need to multiply. So I have 13.5 times X. Then I have 24 times 9. And I'm going to start multiplying them out. So 13.5x and 24 times 9 is 216. Now my variable x is being multiplied by 13.5. So I'm going to divide both sides by 13.5. So x actually equals 16 centimeters. Okay, so today we found missing measures of similar figures and used scale factors to solve problems. I hope that video was helpful. Thank you. Bye.